In case of AC circuit, there will be always a phase difference between applied voltage and the net current that flows, whether we have inductor or capacitor or both in that circuit. And also the impedance or admittance, they don't have real values like resistance or conductance, rather they are expressed in terms of complex variables. And they to represent their values, we use two types of formats. One is called rectangular and the other format is called polar. Now in case of rectangular format, we expressed either this way: x plus I y, or maybe x plus j y, or maybe a plus I b, or a plus j b, or maybe minus. With that we can also, this can be negative also, between real value and imaginary value. So any of this we can use to generalize that format. And in case of polar, we use this format r and then angle theta. Now if we draw the horizontal and vertical axes on linear plane, then this will be our x-axis and this will be our y-axis. Now suppose if we choose a point on that linear plane, and if coordinate of that point, suppose p is xy, then first we have to move linearly along x-axis from the origin 0, 0 along x-axis. This much will be our movement x, and then we have to move vertically along y-axis, and then we will reach to that point whose coordinate is x, y. Now suppose if we want to measure that movement angularly, so it will be, or it can be like this. Say from x-axis, the angle between that point and the x-axis was 0. Now suppose we are moving anti-clockwise to reach to that point. Then when we have reached here, then the angle that is made with the origin, now if we join these 2 points, the origin and the concerned point, then the angle that will be made by that line and x-axis, if we represent that by theta, then we can write that sine theta will be equal to, we know that that is perpendicular by hypotenuse. So pi perpendicular means it will be y divided by this value. If we assume that as r, then it will be r. And similarly cos theta, that can be written as or expressed as, we know that cos theta is base divided by hypotenuse, so it is x divided by r. So from here we can write that y will be equal to r sine theta and x will be equal to r cos theta, where x and y, these are the movement linearly, we can say that the value of the abscissa ordinate of that concerned point. And here r and theta, when we have moved angularly, then this is the distance between origin and that point. That distance is r, and this is the angle how much it is made with the positive real axis. So this way we can represent, or we can build the relationship between rectangular format and polar format. So, and if we want to now express this representation, was the rectangular representation in terms of polar. Now if we want to do the reverse, then what we can do is, if we take the square value of both the sides of both the equation, then we can write this way: r square sine square theta, and then we will have r square cos square theta. And if we add both the terms, then on the right side we can write, it will be from r square sine square theta we will get y square, and then from here we will be getting x square. And if we take r square common, then within bracket it will be sine square theta plus cos square theta, which will give us always 1, and that is equal to x square plus y square. So we can write r square will be equal to x square plus y square, or we can say that r will be equal to square root of this value, x square plus y square. And from here also, again, if we want to get the theta, that angle value, then it can be found this way: r, if we take the ratio of these two, then r sine theta divided by r cos theta. So it can be like y by x. So we can say that tan theta will be equal to y by x. So theta will be equal to tan inverse y by x. That means if we are given a value in rectangular format, and if for some reason we want to get the polar format, if we see that for simplicity of our calculation, in case of AC circuits, if the value was given in polar format, then it would have been easier for us to solve or simplify. Then what we can do is that rectangular value in rectangular format can be converted to value in polar format. For that, either we can use this expressions, this relationship, or directly we can use calculator. But if we use calculator, then this calculation or the conversion will be faster. Now we will see that when we will apply the rectangular format and when we will apply polar format. Suppose if we have two data like this, a plus jb, or maybe a1 jb1, and we have another data a2 plus jb2, and we want to add them, then easily this way it can be done. So the data which are given in rectangular format, so what we can do, we can separately add the real parts, and we can separately also add the imaginary part. Now suppose a1 plus a2, if that gives us a, and b1 plus b2 if that gives us b, then finally it will be a plus jb, and that is again in rectangular format. Similarly, if we want to subtract these two values, then again that can be done this way. So it will be a1 minus a2 plus b1 minus b2, and again that value can be like it can be c plus d. The subtraction, result of subtraction definitely will not be equal to result of addition, so it can be expressed like c plus jd. So if it is addition or subtraction, then it is easier for us if both the data are given in rectangular format. Now with real example also we can explain this. Like if we have suppose 1 plus 2j or j2, and if we have another data like 2 plus j2, then that can be easily added, and the result of addition will be 2 plus 1 3, and here it will be j4. Now if we wish to multiply or divide two data, then if it will be easier for us to multiply or divide if those two data are given in polar format. Now suppose if they are not given in polar format, and still if we want to suppose divide these two data, then what we have to do is first we have to convert this rectangular data in polar format, and similarly the data that we have in the denominator, that will be converted in polar format, and then we will perform the division. So in that case what we will do is simply we will divide r1 and r2. We will divide the r part, and for angle part it will be simply the subtraction of the angle which we have in the denominator from the angle which we have in the numerator. So it will be simply theta 1 minus theta 2. Now it can be r1 divided by r2 if we say that value is r, then r, and theta 1 minus theta 2 if we say that value is theta, then we can finally represent in polar format. Now suppose if we want to multiply these two data, a1 plus jb1 and again a2 plus jb2, so it will be easier for us again if we convert these two into their equivalent polar format. So again if they are like r1 theta 1 and r2 angle theta 2, so what we can do is simply we will multiply their r part. So simply it will be r1 multiplied by r2, and for angle it will be addition of both the angles, so theta 1 plus theta 2, and finally if it is r angle theta, then again it is in the polar format. Now if we want to get back the rectangular the value in rectangular format, we can apply the concept again on the final value. Now suppose again these two values like 1 plus j2 and value like 1 minus j3, these two values are given in rectangular format, and we want to multiply these two data which are given in rectangular format. Still we can do this way also. 1 and 1, it will be simply the rule of multiplication that we know. So it will be 1, then it will be minus j3, and then it will be plus j2, and then it will be plus minus, that means minus j square, and then 3 2s are 6. Further simplification will be like 1, then minus j3 and plus j2, it will be simply minus j, and then j square itself is minus 1, so minus minus it will be plus, and then 6, so finally it will be 7 minus j. And suppose if we have these two data and we want to divide them, then we can also do this way: 1 plus j2, and then that is divided by 1 minus j3. So what we can do is we will divide both numerator and denominator by the conjugate part of the data that we have in the denominator. So it will be, in the denominator we have 1 minus j3, so it will be multiplied by 1 plus j3, and in the denominator also 1 minus j3 multiplied by 1 plus j3. If we do this way, then from the denominator we can eliminate the imaginary part. The value that we will be getting finally in the denominator, that will have only the real part, and we will see next how. So in the numerator, if we simply multiply them, then it will be 1, then plus j3, then plus j2, and then it will be j square 6. 3 2s are 6, and in the denominator it will be a minus b multiplied by a plus b. So it will be a square minus b square. A square, 1 square, that means 1, minus b square. So j3 square value of that. So j square, and 3 square means 9. So finally in the numerator we will have j square itself is minus 1, so it will be minus 6. 1 minus 6, it will be minus 5, and then j3 plus j2, it will be j5, divided by, in the denominator we will have j square again itself is minus 1, so it will be plus 1. 9 plus 1, it will be 10. So 5 is common between numerator and denominator, so it will be minus 1 plus j divided by 2. So this is the basic knowledge of how we calculate or how we simplify an AC circuit, and this knowledge will be more clear once we will solve real numericals based on AC circuit. So with this I end today's class. Thank you.